Chapter 5, Section 4, problem number 13. The monthly amount of water used per household in a small community is normally distributed with mean, let's go and put the mean here, mean is 7,069 gallons, and standard deviation of 58 gallons. Find the three quartiles for the amount of water used. Quartiles. Fortunately, there was a hint there in OneNote that sent me back to Chapter 2 to look at quartiles. And the quartiles, so Q1 is the point at which 25% of the probability is to the left of it and 75% to the right. The second quartile is 50% is to the left of it, less than it, and then the third quartile is 75% of the probability is less than it, 25% greater than it. So I need to find these Q1, Q2, and Q3. So I need to go and find the probability that X is less than, let's see, it's just going to be X star, isn't it? Because it's the probability I'm looking at here. I was getting ready to say, this is the Q1. I was getting ready to put Q1 in for the X star, but it's the value of X that gets us the probability of 0.25%. That's what Q1 is. Alright, so I'm going to have to go back here. So this is similar. This is transform this. So my X star minus 7,069 divided by 58 is going to equal 0.25. So I can figure the value of what's going to go in here for the Z value, and so that Z value that gives me 0.25 is what I'm going to use to set that equal to this. So essentially the Z star is going to equal X star minus 7,069 divided by 58. And that Z star, we can get that by looking at what value of Z provides the cumulative probability of 0.25. And the cumulative probability of 0.25 is approximately minus 0.67 equals X star minus 7,069 over 58. And then I can multiply 58 times minus 0.067 and then add 7,069 to both sides to get me X star. So X, or I could have done all that using the formula right out of the book, but I just try to remember this one. And let's see, this will give me approximately 70/30. So Q1, quartile 1, is 7,030. That's the point at which 25% of the probability is less than that. So 25% of the households have less than 70/30 gallons. Okay, Q2, quartile 2, is at 50%. We could look up in the table and do all the same set of calculations here for this to come up with where the 50% point is, or just remember that the 50% point is where we are at the mean. So this is going to be the same as the mean in this case because our distribution is symmetric about the mean. So it's going to be 7,069 gallons. And so Q3, we can do this a couple ways. This is going to be, once again, the probability that X is less than X star. It's going to be 0.75%, which we can look to say that distance, let's just do it the same way. This is the way to do it. So the probability that Z is going to be less than, back to my X star, I have star minus 7,069 over 58. It's going to equal 0.75. So my Z star is going to equal my X star minus 7069 over 58. And if we're going to 0.75, we actually see that 0.67. It's on the opposite side, so it's essentially the opposite sign. So again, here I can solve for X, cross multiply by 58, and add 7065 to both sides. Where did that 5 come from? That's a 9. Copied that down wrong. And so my X star will be 7108 gallons. So there, I got them. I've got my first quartile, second quartile, and third quartile. Just kind of looking at it, making sure that number is reasonable, and that does fit.